Hello and welcome. India's manufacturing future may be bright, but the bright also depends on the level of indigenization and local innovation that happens, particularly in technology-led engineering. To talk about this and some interesting stories in that context is Kannan Lakshminarayan, founder and CTO of Vortex Engineering Limited, based out of Chennai. Kannan, thank you very much for speaking to us.
My pleasure.
So, you created some very interesting companies. One is a ATM making a machine, which is also economical ATM machines. You also built a textile machinery company, and you've also built a third company, which you've not told me about.
Yeah, the third company is into technology solutions for skill training.
Okay.
We make simulators based skill training tools.
Right. So let's talk about the first two, right? And this whole thing springs from your thinking that technology or engineering has to be localized or has to be bottom up, right? So tell us about the ATM story. What made you think of making an ATM against so many multinationals who all make ATMs aimed at countries like us?
Well, it's not that we went out trying to compete with the multinationals.
Yeah.
When we were trying to address the problem of financial inclusion, context where 80% of people in rural India are not having a bank account.
Right.
And when we looked at what is it that you can do to bring them within the fold, because they obviously need so many financial services, it appeared to us that you need a solution that makes it profitable for a bank to deliver those services. And when we looked at the different challenges that a bank would typically face, we recognize that an ATM machine is the way to go, but a conventional ATM will not suit such a context for a number of technical reasons. So we drew up a sort of wish list of what should an ATM for these people be like, and then went about building it. So this was targeted at India, particularly tier 2, tier 3 towns, rural areas, and meant to operate in wide variety of ambient conditions with low energy in contexts where you have fluctuating power or no power, and where the quality of currency can be very widely varying. Nobody carries a wallet, they all bundle it in their clothes. And these are the kind of currency that you must reliably be able to dispense.
Right. So what would your cost be of your ATM versus, let's say, a similar, not a similar, but let's say the normal ATM one would see in cities?
I think our cost is about 30% lower than a conventional ATM, but more importantly, the cost of ownership, if you take a 5 to 7 year period, is significantly lower because of low maintenance, low power consumption, and a number of other factors.
So what are the 2 or 3 critical areas that you had to differentiate when you were building your ATM, or do differently? I'm assuming on the engineering side.
So the core engine is what we built differently, which is the cash dispenser, how it picks the currency and dispenses it. And really the challenge we were trying to attack was that when we started our work, the industry benchmark was that a dispenser would consume close to 1,000 watts. And to me it looked unacceptable, because we all count notes. So in that sense, you are a cash dispenser and so am I. And we do it with our fingers, which probably consume 3-4 watts. A finger cannot generate more power than that. So why is an engineered machine so much more wasteful of energy? And the reason we were so concerned about energy is not merely because we want to pay a smaller tariff at the end of the month, but because in most of the places where we were seeking to deploy, energy is just not there.
Right.
And then to make backup power affordable and ensure what is called uptime, availability. You can't tell somebody there's no power, come and try your luck after 2 days when they need the money desperately. So this is the reason we were very, very mindful of the energy, and this meant that we had to completely re-engineer the core mechanism of cash dispensing.
So can you in layman's language explain what is the difference? I mean, how is it closer to like using my hands versus what conventional machines use?
I think the good thing is that when we started designing the thing, we had no idea how a conventional ATM was built.
Okay. So you didn't take one and strip it down and so
no, we modeled it after how we would count, because for me, being biased by the conventional design meant that maybe I'll be 20% lower than 1,000 watt, but that's not acceptable.
Right.
I wanted to start with the way we count notes as the benchmark, and we used mere gravity, which is a free source of energy, to great advantage. And at every little step, we just try to see how any superfluous usage of energy is avoided. For instance, in a conventional ATM, every piece of currency is conveyed over a long distance, 2-3 meters, before it reaches the final destination, and one by one these pieces are assembled before they come to you as a bunch. And in one architecture of our product, we just pick all of them one after the other and put them all in one cartridge and then convey the cartridge, which is a lot more efficient than conveying things one by one. So there are a number of things that we have done in detail. We have about 8 patents on different aspects of this, and we really brought down our ATM consumes a peak power of 50 watt, which is inclusive of the screen and other things.
And would you say that's the most differentiating aspect in your ATM, apart from the cost and everything else?
The other important thing is that even with urban ATMs, we all have the experience that when we go, they say the ATM is down, and very soon the maintenance team will come in a
armored van
or something, and they will strip open the whole thing, clear whatever is the problem, and then go away. Now this turnaround time, which would be a few hours in a city, if the ATM were located in a distant remote location, would take several days.
Correct.
So that we cannot afford. So we had to build a dispenser that's a lot more reliable and can also handle very wide variation in the quality of currency. In the cities, typically what is called bank chests, they issue the currency of a certain grade, what is called ATM fit currency, which is very good, which is very good currency. But in the kind of places that I am talking about, the people come to the counter and give deposits to the counter clerk, and all of this is stacked, it is ironed out, uncreased, because it's come from folds of clothing, and then the same thing is just put. It could be soiled, it could be torn, it could be folded, and all these variations have to be handled a lot more reliably, because if the paper gets jammed, then it's several days of outage before somebody can reach there.
Right. So how many ATMs do you have on the field now, and what are the targets that you've set for yourself?
Well, we have about 1,000 ATMs so far across all over India, and we are looking to deploy another 3,000 this year, and probably 10,000 the year going forward. We are forecasting a very rapid growth, but this rapid growth is not something that only we will enjoy. It's the entire industry has grown because we sort of demonstrated the model by which the reach could be significantly expanded. So actually India is the fastest growing ATM market in the world, and we are going to have in the next 3-4 years 200,000 to 300,000 ATMs.
Right. So let me come back to the point that you made earlier. You said that you wanted to address a problem of financial inclusion, right, and how to dispense money, and that's how this idea was born. So what's the larger lesson in this in terms of approaching problems that we face at the bottom end of the pyramid? And secondly, how does this in some ways link to the larger challenges of manufacturing in India?
Okay. See, the important thing is that we need to spend more time understanding the problem than probably we need to spend in finding the solution.
Okay.
So when we take a solution developed in some other context, then we are so obsessed with what the box that we have that we want to somehow make it fit, round peg in a square hole. But instead, if we were to look at a specific context and see what is really needed there, and then build that ground up, it is probably much easier and also much more aligned to the market we are seeking to address. And it will also be free from flab. You are not saddled with a whole lot of legacy features, if you can call them that, which are not relevant in the particular market that you are trying to satisfy.
Right.
So, so this is the kind of thing that requires a unbiased and ground up approach, rather than looking over one's shoulder and seeing what somebody else is doing. How can I?
And that also you feel links to the larger manufacturing story in India. That means the real opportunity lies in finding such solutions and building them. I mean,
absolutely. For example, if I look at manufacturing as a sector, there are a lot of things about how we do things in India which are very different from the way things are probably done in USA or Germany or Japan. And for a country to grow and become strong, it has to be along the grain of where its strength is, not against the grain. So if we try to do something that is very orthogonal to our ethos, then we will always be trying to imitate somebody and be a poor cousin of such a person. So for example, the way Japan picked up in manufacturing a few decades ago was based on way of organizing which is very different from the way things happen in the US. And in India, it's a completely different paradigm. If you look at, for instance, the largest manufacturing sector in India is textiles, which is one of the areas I work in. And you will even see for something as intangible as IT, a lot of swank buildings. But you would have never seen a large swank building saying that this is a textile factory. The textiles is organized as a large number of very small, tiny, networked clusters and hardly catches your eye. But it's the largest employer after agriculture, and it's one of the top foreign exchange earners. It earns more foreign exchange than IT. And it's all done by people who are barely literate, very humble. And we need to recognize how the whole network ecosystem works and build technologies that are aligned to it, rather than trying to just plug in something got from somewhere.
And then that's how you're approaching the textile problem. So let me ask you a general question as we come to a conclusion of this chat. What are the kind of things that you're seeing today that you feel we should be thinking of solutions for?
Well, there are a lot of big challenges which, when we drill down deep, can open up a number of opportunities. It's not so. Actually, the large number of challenges that we are facing, whether it's climate change, whether it is killing of a large number of people, whether it is sustainability, environment, whole lot of things. Each of these presents an opportunity for a large number of innovative solutions, and a solution deserves to be called a solution only if it can actually take root in a particular environment and thrive. And the way things work in India, what kind of things would succeed in India is very different. The soil is very different, if I may say so. And we have to actually have the confidence to say that we will go figure out our solutions and build them, rather than trying to, I'm not saying be insular and don't take things from elsewhere, but the definition of the problem must be ours, not somebody else's.
Right.
Solution pieces, components can be got from anywhere.
Right. And you feel that climate change and sustainability are issues that you are personally focused on, or these are things that
Yeah, the one other thing I'm importantly focusing on now is what is called the skill gap, which all of us are familiar with. India is the youngest country in the world, but most people have no employable skills. So you could skill them and convert this into a largest opportunity, what is called the demographic dividend, or you could self-destruct as a society because you will have the largest number of hungry, unemployed people in the world. And so this is a context where we started seeing why is it so difficult to crack, and skilling, by which I mean hands-on skills as opposed to mere textual knowledge, is a different ball game. You require laboratory, you require workshops, you require consumables, you require equipment, all of which costs a lot of money. And if it's mere textual knowledge, information transmission, you have e-learning, but there is no e-learning for a hands-on skill. And that's when we thought, why can't we build simulators which can impart over as much as e-learning as effectively, which means 80% to 80% extent, without needing consumables, without needing infrastructure, without requiring skilled trainers, impart skills in a mass way, so that it is very low cost, very affordable, because today we are only able to produce 2% of India's needs annually in relation to the demand. And we have to really think out of the box, think how you can bring down costs and other obstacles by 1 or 2 orders of magnitude.
Right. Kannan, we've run out of time. Thank you so much for speaking with us, and wish you all the best with all your 3 ventures and more to come.
Thank you.
Thank you so much.